Hello, everybody. I am Amélie Espérou from iTrans, the French competitiveness cluster in the railway industry. We are, of course, ERCI member, and I'm very happy today to introduce you the next presentation that will be made by Railenium, a member of iTrans. So what is Railenium? It's the French Institute for Technological Research dedicated to the railway sector. It supports the actors of the railway industry in the development of their innovations. So research activities are organized into different domains. We have human behaviors, railway safety, artificial intelligence, energy, assets management. So the next presentation will be done by Jana Carli. Jana is an engineer working in the field of ergonomics and human factors. She started her career at Railenium in 2022, where she got the opportunity to work on a wide range of rail projects, integrating HOF and ergonomics in a variety of ways, mainly human reliability and user safety. So Jana is going to give you an overview of human factors in railway. Jana, the floor is yours.
Thank you, Amélie. So I will now share my screen. Yes. So today I will present an overview of the integration of human factors in railway. So I was going to say a few words about Railenium, but you already done so, Amélie. So yeah, indeed, Railenium is a French institute for technological research, which is dedicated to the railway. It was founded in 2012 and is based in the north of France, in Valenciennes, but we also have offices in Paris. So our role, as Amélie said, is to help the actors of the railway industry to develop their technologies and innovations. And so, yeah, the research activities are divided into 3 domains, which are human behaviors and railway safety, which I am part of. And there are also artificial intelligence and energy and assets management. And in fact, the research follows a roadmap set by the CORIFER, which is the Council for the Strategic Orientation of the Railway Research and Innovation. And this roadmap deals with 4 major topics, which are the future of railway industry and infrastructure, inclusive mobility, zero carbon trains, and smart trains. And so, of course, human factors play a role in each of these topics. So I'll now move on the main subject of this presentation, which is integration of human factors in railway. I will talk about automation. I will talk about technology and interface development, as well as user integration and system design. So here we have an AI-generated picture, so generated with artificial intelligence, and it shows what could be the future of the railway infrastructure, at least if we have a bit of imagination, of course. And we can see that the human is put at the center of the picture, and it will be the connecting point between the element I will now focus on, which are rolling stocks, operational control center, and user integration. So the first element we'll have a focus on is rolling stocks. And so we'll be particularly interested in the main actor, which is concerned by the evolution of this system, which is the driver. So to give a bit of, to give a bit of context, today the railway industry, just like any industry today, move towards more automation, and we're talking about train automation, of course. And when we talk about autonomous train, we are talking about grades of automation that goes from grade 1 to grade 4. So grade 1, it's where all the monitoring and driving activities are entirely managed by the driver. And grade 4, it's full automation. And so these driving and monitoring activities are managed by the autonomous system. And in between, we have modes where these driving and monitoring activities are shared by both the driver and the autonomous system. And so today in France, it's the driver who is responsible for management of monitoring and driving of the train. And so we're at grade 1. And today, with the evolution and development of autonomous train, so from grade 2 to grade 4, and with the aim of increasing transport capacity, system safety, and efficiency, we're heading towards a redesign of the train drivers' activities. And so in that matter, several challenges need to be addressed. And I will share with you 4 major challenges that I think are very important and interesting. So one of these challenges is about how the driver will manage mode transitions. So mode transitions, it's when the autonomous system is switching from one level of automation to another. And so how to design the interface, how to make the driving activity evolve, to make sure and to make sure that we can avoid some potential issues, such as, for example, mode confusions. So mode confusions, it's, for example, when the driver, maybe because of a lack of situation awareness or things like that, it won't be able to tell in which mode the autonomous system is, and if the autonomous system switches in another mode, the driver won't be able basically to tell in which mode the system switched. And so, of course, the working procedures will have to evolve as well as tasks, and so will as well the driving desk. So, which means that new elements might be added or removed from the driving desk, especially taking into account how the activity is evolving, of course. The monitoring of partially autonomous train will be made remotely, which means that there will be at least a deterioration or worse, a loss of sensory perceptions that the driver usually uses. And so a major challenge lies in how do we rebuild an adequate level of situation awareness to address this loss of sensory perceptions and to ensure the traffic safety. And so it will be interface development that will play a huge part in supporting these evolutions, especially with the development of the use of advanced technologies to convey information that the driving activity requires. For example, the speed of the train, and it could be done with other sensory modalities. So today, for example, the speed of the train, the driver managed to feel it, for example, to see it, of course, with the landscape moving, but also feel it with vibrations. And so how we can do that when the driver is not in the train. And it could be done, for example, I don't know, with lights, for example, or with also kinesthetic technologies. With partially automated train, the remote drivers the remote driver's activity will be more about monitoring, which means that the driver will be subject to loss of alertness. And so the monitoring of alertness will be very important, very crucial. In France, for example, today, the system that we have to monitor alertness, which is called VACMA, and which is like, in fact, a pedal that the driver have to activate and deactivate every couple of seconds to say, yeah, I'm conscious. Well, this system today faces several challenges, and for example, the driver's action on the system became more automated than conscious. And so, yeah, this system really needs to be redesigned. And if we want to talk about safety, and we all know that railway safety is really crucial, well, the human reliability will play a huge role in helping in the safety demonstration of autonomous systems and autonomous trains, in that matter. So you might all be familiar with a principle that rules in the railway sector, which say that the modification of an existing system must be managed so that the global resulting safety level must be at least equivalent to the one of the existing system. And so in France, this principle is called the GAME principle. So GAME, it's globalement au moins équivalent. And this principle is often associated with the ALARP principle in England. So ALARP stands for as low as reasonably practicable. And in Germany, we have the MEM principle, and MEM stands for minimale endogene Mortalität. And so both of these principles are not exactly the same as the GAME one, but yeah, the idea is when developing a system, we must make sure that the risk is minimal. And so, yeah, to demonstrate this GAME principle on driving-related functions that will be transferred from the driver to the autonomous system, the human reliability has to be assessed. So that was about rolling stocks and some challenges that this system face. And I will now move on another element that we'll have a look at, which is the operational control center. So the operational control center is where the supervision and management of traffic take place. And so in the near future, what will happen is that we will have operators, a procedure, for instance, on train switching and scheduling on areas they won't have full knowledge of. And so we must ensure that they will build a good level of situation awareness. And so the idea is to develop new tangible interfaces that will allow for the visualization of the impact of decisions that the driver will make, and what is this impact on the traffic organization. And so the idea is that the driver won't actually do an action on the technical system. It will be about simulation. And so, yeah, the operator will be able to simulate, in fact, actions by, for example, moving trains on the interface. So, of course, not the real ones, but the digital ones. And they will be also able to navigate between distant geographical areas to see the impact, for example, of a train delay, or if there's a modification in the direction of one train, they will be able to see in real time this impact, but without actually doing it, which is not possible with the current system that we have to visualize train switching. And so these new interfaces will ensure that good and safe decisions are made in complex situations, and that will result in an increased punctuality and an increased transport capacity, of course. And we also have less static trains and less human errors. And the last point that I will talk about here is about user integration. So user integration is here modelized by this train station, because I think train station is maybe the most accurate interface between the railway system and railway users. And I think we can all picture today today's train station crowded with travelers, and these travelers sometimes will struggle to find information about directions, for example, directions inside the station, information about their train departure platform, or things like that. Maybe there will also be running to catch their train because the bus that took them to the station was late. And because of all these potential situations, we really need to understand the human behavior to improve, of course, train coaches' capacity, to reduce also dwelling time, or to optimize multimodal journeys. And these challenges could be addressed, for example, by having modular train coaches. So the train coaches, the layout of these train coaches could be adapted in real time, depending on how many people are taking this train, maybe depending on what is the equipment of the users taking the train. And of course, it could be also addressed by having purpose, do everything we want. So typically for multimodal journeys, there could be interfaces better made than the one that we have today, where if there's a delay in the multimodal journey of the user, which means that maybe the user is taking a train and after a bus, there's a delay on the train journey. The application could help the user to find the best solution for another bus to take or another mean of transport for their journey. And so to capture this human behavior, Railenium is developing an experiment center, so called Human Behavior Experiment Center. And this center is using a scale 1:1 modular testing platform, which uses mixed reality as a main asset. And so today's the platform is used to develop safety systems for railway user on specific areas of the railway environment. So it could be, for example, by the rail tracks, so on the train station platforms, but it could be also inside the train station hall. And yeah, I won't be able to give too much details about the studies that are currently conducted on the platform, but I can give a bit more detail about the mixed reality system. So in fact, the virtual reality system is said to be adaptive, which means that any environment could be modeled using virtual reality. And this virtual reality system would be coupled with, and is coupled, because it's already the case, is coupled with purpose-made physical elements, such as, for example, the train station platforms, but also the rail tracks. And the aim is really to make this platform multimodal, which means that we want to couple the current system that we are using, so the mixed reality one. We want to couple it, if it's possible, and I think it is possible to couple it with other measurement systems, such as, for example, force plates, for biomechanical measurements, or markerless technologies to capture the body movements and kinematics. But it could also be coupled with a driving desk or remote driving desk to witness the interaction with technical systems at level crossing, for example. And so, for Railenium, this experiment center is really an opportunity to use all the levers offered by virtual reality to incorporate knowledge of the human behavior in the development of safer and more efficient systems. And our ambition is to host experimentation in various domains. So, for example, it could be the training of operators performing risky tasks. It could be for the evaluation and validation of industrial concepts. It could be for the evaluation of some layouts, environment layouts for people with disabilities or with reduced mobility. And it could also be, and we hope it could be used to host, for example, awareness campaigns on railway risk and safety. And so, yeah, we really can't wait to see what we'll be able to achieve with this experiment center. I put some picture on this slide of the platform and of the virtual reality screen that we have. So you can see that it's quite much detailed. And so, yeah, we can't wait to see what are the projects that will be able to integrate. And so, yeah, we welcome any project. So if you know companies that are looking to, in France at least, I guess, because it will be easier as it's based in France, but any project that requires the analysis of human behavior will be really honored, like to host it in our experiment center. So that's the end of the presentation about the integration of human factors in the railway sector. And I will finish with this takeaway message saying that in a world where automation plays an always greater part in system development, human contribution has never been more relevant. So thank you, everyone, for your attention. And yeah, I would welcome any question that you could have.
Thank you very much, Jana, for this very interesting presentation. I'm checking the chat. Yes, we have one question. Based on your experience, how can GOA4 automation handle degraded conditions in railway driving?
Can it be written on the slide or?
Yes, it's. I don't know if you can see the chat.
Yeah, I will working on it. Just a minute. Yeah.
Thanks, Lutz.
No worries, thank you.
Because world meeting came nearly at the end of the presentation, so I have to prepare it. But the first question is already visible now, and I will forward it. Yeah. That means based on your experience, how can rate of automation for automation handle degraded conditions in railway driving?
Should I first answer the first question?
Yeah, for sure.
Yeah. No, or should I wait for you to write all the questions as you want? So yeah, if I move on the if I move on the first question, so what is the primary interest of developing an experimental center? Well, using virtual reality, really enables us to reproduce real life situations with limited biases and with a guarantee of the user safety. Indeed, today a lot of situations implying human factors can't be studied in details in the real environment, and that is for several reasons. It is because the event studied can be difficult to witness due to the rarity of its occurrence. It can be also because the situation that we want to study can put the user's life at risk. And it is also because the variables, can't be fully controlled as in a closed environment and controlled environment. And it's also because the situation can't be reproduced in the exact same conditions twice, like in the real environment. You can't have twice the same situation with the same conditions, but this is possible. All of these challenges can be addressed with virtual reality. And so with this experiment center, our will is to use virtual reality in an open area. So the platform is quite huge. And so this open area, it enables us to ensure that the immersion is sufficient to have the
An activity is
in a real situation. So that's really the interest of this experiment center. For the second question, based on your experience, how can GOA4 automation handle degraded conditions in railway driving? What I know is that for a full autonomous train, there will be the possibility to retake the control and the monitoring of the train from a distant desk. With an operator being able to take back the control of the train in a degraded conditions in a railway, and yeah, that's about it. Challenges: whose responsibility to inform the user regarding the human factors? I think it's a responsibility. It can be the responsibility of anyone. Of course, it's the responsibility of us human factors specialists. But I think it's also a lot about the responsibilities of the companies that are working in the industry, but any companies, because human factors are everywhere, basically. Like they play a role in any activity, in any domain. So yeah, of course, the management will have to inform their work about that, and the company selling products or everything. Human factors should be integrated in their products and their information campaigns, maybe, or things like that. But yeah, I think it's something to deal with everyone. Whether it is of the system manufacturer, supplier company, or the system user company. Is this question having something to deal with the one just above?
Yeah, I think these are more or less the challenges Astrid asked in their presentation, and we ask the audience to give the challenges regarding human factors for the railway system. And maybe these questions should not be answered by you totally, but give us an idea what is the real topic of dealing with human factors in the railway sector. And maybe, Astrid, you can comment a bit on these challenges. Is that what you are expecting to hear from the audience, or?
I didn't expect anything. I mean, or I expected everything. So that's. But as Jana said, I think it's more related also to to the first question. It's not really a question whether it's the system manufacturer, supplier company, or the system user company. Well, it depends who is developing for the customer, right? And sometimes it's good to cooperate in order to make the customer basically to make the user of the system happy. So if it's passengers, for sure, everybody in the system should try to make them happy. And to integrate human factors as such. I think also I liked how you put it, Jana. I think everybody is responsible for that in the chain of development. This would be good. And then it depends on who is the user actually. Is it the passenger? Of course, the whole service chain. But if the user is somebody within the company, it should be part of the change management and of the information processes within the company, basically. Yeah, and the best way to inform the users via document or training, yeah, I don't know. Actually, the users should be informed as directly as possible. Training is really hands-on stuff is better than to have to read a document. And also they shouldn't just have to be informed, they should be integrated in the whole development process. And their requirements should be taken into consideration as well. So there are requirements regarding the procedure, for instance. To inform them as a last step of the whole development chain is not what you want to do. You want to have participation.
Yeah, thank you. Thank you very much, Astrid. And yeah, regarding the last question, regarding the modular vehicle interior, could you elaborate on how this would be achievable? We can't tell in detail because it's about an upcoming project. But yeah, we were thinking, of course, we can think, of course, about the seat, the modulation of the seat layout, or about the yeah, I will say seat because like I can't have in mind exactly what it will be about. Also like the, I don't know how to say that in English, I'm sorry. I'm really sorry, but we take in account, of course, the I don't have the word in English, but all the part of the train, of the technical part of the train, because that will play a role. We won't be able to do everything we want because of the system that is included in the trains, especially like the wheel systems and everything. So that's it. I won't be able to tell much because it has not been addressed already. It's in an upcoming project.
So I lately decided to have a very last question because I guess it is very interesting. And if you allow us to be some minutes late in this webinar now, how do you integrate users in the development process if you have 1,000+ users?
That's a really interesting question, and that has exactly something to do with the platform I was talking about just before. Because, for example, the experiment center that we are developing, the platform will be able to be up to 1,900 meters squared. And so we'll be able to welcome a lot of users, like several hundreds. And so we will be really able to simulate, for example, if we are talking about the flow of users inside a train station, it will be possible to simulate that with a lot of users on that platform. So this is our way, for example, to integrate that many users in the development process.
But thank you very much for both presentations. We have a little program still to